just like a lawn sprinkler. Chunks of dusty material come off the comet's surface too. Some of this, from comets that have long evaporated completely, is the origin of the shooting stars that we often see in the night sky. We have placed a spacecraft in orbit around Ceres, the largest of the asteroids between Mars and Jupiter. 1/2 of the volume of this object is ice, overlain by a dark, rocky surface layer. Ceres is 1/3 the size of the Earth's moon. Close up, we can see the geological history of a world dominated by a mixture of ice and rock. In some places, impacts of meteorites have revealed fresh, icy material. In others, movement in the ice itself has built up peculiar, isolated mountains. All of these worlds cast a mirror on the geology and chemistry of our own Earth, allowing us to see our own world as one example among a multiplicity of planets, not just now in our own solar system, but also orbiting many of the stars in our sky. Galileo saw strange features around Saturn, but could not identify them through his small telescope. Were they moons, high mountains, a misshapen, non-spherical planet? Thanks to detailed exploration of the Saturn system by the Voyager and Cassini spacecraft, we have an enormously improved view. Now we know. The rings are a vast system of icy fragments orbiting Saturn. On this scale, the Sun, the Earth would appear the size of a blueberry on a dinner plate. The rings are tens of thousands of miles wide, yet only a mile or so thick. Perhaps they are the remains of a moon that never formed. Shaped by Saturn's gravity and the gravity of its many moons, the ring particles create a complex dance around the planet. In general, the inner parts of the rings move faster than the outer parts. Like cars on a busy freeway, they're constantly passing each other. But there are other strange effects that the forces of nature conspire to produce. Huge radial spokes continually appear and disappear in the rings. Perhaps some interplay of magnetic fields and electrical charging of dust particles causes this. We're not quite sure. On the outer edge of the rings, the F-ring is a braid of particles, woven by the motion of 2 moons, Pandora and Prometheus. As these irregular chunks of ice, each the size of a town, hurtle around the inner and outer edges of this ring, the tugs of their small gravity fields send the ring particles moving to and fro, spinning out a complicated, ever-changing pattern of oscillation, very much like the strings of a musical instrument. Beyond the main rings, there is a much larger, faint ring, known as the E-ring. This is formed by water vapor erupting from the small icy world Enceladus. Enceladus, like Europa, may well have an ocean buried under its icy surface. In fact, we wonder if such subsurface oceans are common in the cold outer reaches of the solar system. In this case, water erupts from cracks near Enceladus' south pole. Freezes into small, icy particles, and spreads out into a gigantic flat ring surrounding Saturn. Seen from the shadow side of Saturn, with the sun behind the planet, the ring is illuminated by scattered light, like fine smoke. One small point of light in this picture is not from the Saturn system. It is our own tiny ocean world, 1 billion miles away. This is an immense swirling anticyclonic storm, large enough to swallow the Earth 3 times. The Great Red Spot has been a part of Jupiter's atmosphere for centuries, as long as we've been observing it through telescopes. The entire storm rotates counterclockwise every 6 Earth days. Winds at the periphery of the storm blow at speeds of 300 miles per hour. The striking red colors are produced by sulfur-rich gases. The more vivid shades of red are produced by higher temperatures, deeper in the atmosphere. As far as we know, Jupiter's atmosphere, like the other giant planets of the solar system, extends on into the interior of this world until, without reaching a solid surface, the extreme pressures of the overlying layers of gas compresses it first to a liquid and then a solid. Saturn, too, has a gigantic swirling storm. Strangely enough, this one is at the north pole of the planet. It's a hexagonal pattern of winds rotating in synchronization with the deep interior of the atmosphere, once every 11 hours. Each side of this hexagon is the size of our Earth. Strangely enough, there is not a similar sized storm pattern at Saturn's south pole. Uranus is the smallest of the giant planets. As a result, its atmosphere is cooler and less active than its larger cousins. The atmosphere is tinged blue by a small amount of methane. Uranus rotates on its side as it orbits the Sun, perhaps the result of an ancient collision. Sometimes the poles of Uranus point directly to the Sun, and the banded clouds show a strange bullseye appearance. Neptune, the outermost giant planet, is slightly larger than Uranus. It has a more active atmosphere. That included a giant anticyclonic storm similar to Jupiter's Great Red Spot. This storm, the Great Dark Spot, was smaller though, only big enough to swallow the Earth once. The storms on Neptune seem to have lives much shorter than those on Jupiter. Pictures from the Hubble Space Telescope tell us that the Great Dark Spot has already vanished, to be replaced by a similar storm. In this outermost giant planet, wind speeds are extremely high, 1,300 miles per hour, almost faster than the speed of sound. Fine, wispy clouds of methane ice crystals are swept around the planet by these winds. As we pass beyond Neptune, it forms a giant crescent in our sky. Its companion moon, Triton, lights its night side. Aside from a vast swarm of small icy comets, we are now at the outer edge of our solar system. The sun here is a tiny point of light, almost 2,000 times dimmer than in the Earth's sky. And now, to move much closer to the sun. Our neighbor Mars is our sister world. Its surface water long depleted, the desert sands of Mars are scoured by winds. Humans now have explored this cold, arid, dusty world for 50 years. Currently, we have 5 functioning spacecraft orbiting the planet and 2 live rovers on the surface, Opportunity and Curiosity. Curiosity's arrival, shown here, occurred 3 years ago. What have we learned from this detailed study? We know now that Mars was warmer and wetter in the past. Features like these ancient dry river valleys and chaotic canyons record an ancient history, perhaps billions of years ago, when Mars was the home of large amounts of liquid water. There were lakes, rivers,